And welcome back to Mr. Gregor's Math. Today we're going to be looking at function inverses. And actually we're going to take a look at what a function inverse will do, what it will look like on a graph, and how to find them algebraically. So we'll start with this graphical picture here of our function f. And suppose we wanted to figure out some values of f. So suppose we said, hey, what is the value of f at a? So we would go to f and we would look along it until we find our value of a on the x-axis, and we would read off the corresponding y value. So the value of f at a is b. Thinking about that process in forward again, we're on f, we go to where f has an x-coordinate of a, and we read the y value. So thinking about the inverse of that, we would want to find some sort of function where we could put in the y value and go to f where we see that y value and read down and find the a value. And so you would see f at b equals a. Now, it's not actually going to be f. If we're talking about this process of working forwards, we're talking about the function. But if we're talking about the process of working backwards, we're talking about the function's inverse. And we denote it like that. We would say f inverse of b is a. Now, it's helpful to have an algebraic or graphical rule for these inverse functions. Now, the graphical rule is quite easy to see. Because all we're doing is switching our x's and y's, what we have to do is find a way to switch our x and y axes. And so we can think about rotating it about the line y equals x. And so I'm going to draw the line y equals x, which should just be like this. And this is my line y equals x. And so what I'm going to do is I'm just going to reflect everything across there. So you can see the x-axis would reflect up to the y-axis. And now this point at AB is going to reflect down here to BA. And so this would be a point that gets moved across the line down to here. Now I realize because of the perspective of my camera, it's a little bit less accurate, and because of my diagram, it's not quite accurate. But these would have coordinates B and A. So we would just see the x and y coordinates flip. And now this function seems to have a curvy thing and goes up. So I'm going to go up to here, and I'm going to imagine drawing a line across. And it'll reflect exactly across, so it should be the same equal distant point. So it'll be there. Do the same thing for this, so I'll draw a line across. So it'll be about right there. And this arrow seems to be going infinitely tall at about this point. So it's probably going to go infinitely horizontal, probably somewhere right there. So I'll try and draw this as smoothly as I can. And I think I did a pretty good sketch of it. So this would be the function f, and this would be the function f inverse. So we can draw a graphical inverse by just reflecting about the line y equals x. Now, how about finding this thing algebraically? For that, we're actually going to need to define